problem, but we're going to look at it and see if we can match it up to any of the op amps that we know. And so it's not exactly like any of the op amps that we know, but if we look at just part of it, so if we look at this part of it, so there is more, but just that part of it right there does match one of our op amps. And so if we go back and look, we see that it matches the non-inverting amplifier, which is one that you're supposed to know. So the non-inverting amplifier has our gain of A equals 1 plus R. R2 over R1, where R2 is the top one. Okay, so for just this part, if we had that this was our source, and so it's Vs prime, it's not our actual Vs, but it is our Vs prime, we know that VO equals our gain times our source, or VO equals our gain for the non-inverting amplifier is 1 plus R2 over R1 times our source. Our VO equals 1 plus 70 over 10 times our source, or VO equals 8 Vs prime. All right. Then we also can say, now I'm going to do this differently than I did last time. It's get the same result, but we're going to look at it in a slightly different way. Imagine taking this Vs and just kind of like stretching this wire out so that I had Vs on top and then a 5 kilo ohm resistor, and then I had Vs prime here, and then a 20 kilo ohm resistor, and then I have ground down there. Now there is more coming off this Vs prime, but like we were talking about before, that doesn't really matter. We can still find what the voltage is here at this Vs prime. And so we can use voltage division here. So voltage division tells us that Vs prime equals our total voltage, which is Vs, times the voltage from ground to Vs prime, which is 20, over our total resistance, our resistance from ground to Vs prime, which is 20, over our total resistance, which is 25, or Vs prime equals Vs times 4/5. Now that's the same thing we did last time, or same answer we got last time, we just did it in a different way. Last time I did it with currents. This time I did it with voltage division. And then, let's see. I would do the same thing with voltage division on the VO and VL, where I had ground here and VO here and VL here. That's this branch right here. And it looks like, so again, I would say that VL equals 1/2 VO because these two resistors are the same. They're both 4 kilo ohms. which I only know because it's supposed to be part of the problem that I left out. So VL is 1/2 VO, and we are looking for, the problem is asking for the gain of VL over VS prime. And so I have enough here if I just put it in the right order. So VL is 1/2 VO. VS prime is VS times 4/5. That's not what I want. I want to say that VS prime, so I still need, because this doesn't help me, I need to use this right here because I'll need to cancel out my VOs. I need to say that VS prime equals 1/8 VO. And then I can use this one and this one to say 1/8 VO
Maybe you meant VL over VS instead of VL over VS prime.
I think that's what I meant. Thank you. VL over VS. But I still need this. Did I?
Did I?
What did the problem ask for? Hold on.
It does say VL over VS.
VL over VS, yeah. VL over VS. So VS is, so yeah, VS is 5/4 VS prime, which is 5/4 times 1/8 VO. Now I have it. So now I have 1/2 VO over 5/32 VO, which equals 3.2. So that's our gain. So I can't say that I think one way is any easier than the other, which is why I don't spend a whole lot of time memorizing the different types of op amps. But you might have liked this way better than the first way, because in this one I didn't use any of the rules of op amps. I just used voltage division and what I knew about that particular op amp. Okay, so any questions?
Where did you get the VS prime equals 1/8 or times V0?
I got it from my original knowing that this was the non-inverting amplifier. So because this was the non-inverting amplifier, gave me that A equaled 1 plus R2 over R1, and that relates VO with VS. In this instance, that is VO, but this was VS prime. And then, so I plugged in to here, and then I plugged in my values for R2 and R1, and so this is 1 plus 7 was 8, so VO equaled 8 VS prime.
Oh, okay, sorry. Yeah, I just didn't see. Like, I was confused on why it was under that 4 kilo ohm.
Why it was what?
The
Under
other-
this?
Yeah, but it was underneath the other one. Where it was like 4 kilo ohms. Never mind. I understand.
Yes, it didn't really go with that. Yeah,
Yeah, no,
I was
that's
just
why I was-
copying it. Yeah.
Okay, so looking at the diagram, the reason why we use VS prime when we're using it and like the gains is because that's what's directly going into the op amp, and then when we actually like solve it out later, we're taking that into consideration. So that's why like VS, like you have to use VS prime in it.
Right.
To solve for it. Okay.
Right, because we were using this formula right here, and for this formula, the gain is V out over Vn. That's A in this diagram. So we had to match up what Vn was in our diagram, which was Vs prime. But then we were just finding what the question asked for. And the question asked for VL over Vs. And so that's where we went from there. Usually the gain is defined as V out over Vn, but here is VL over Vs. Okay, other questions?
So had that not been that resistor, well, I guess it's the matter of there being two resistors. I was just saying if the resistor wasn't there, if there would have been a need for VS prime.
If neither of these resistors were here.
Yeah.
Yes. Yes. Yes.
So the obvious draws no current, but like how is it supposed to convert like an AC if it draws no current?
Okay, there is no current coming in here and here, but it is powered. That's that VCC. There is a lot of stuff going on inside that op amp. And so you're saying it draws no current. Well, IP and IN are 0, but that's because of the feedback from the output of the op amp and what's going on the inside. So it's because you have this feedback in all of your op amps. You will see some feedback, and so I mean you're always coming back, and so you can think of currents canceling each other out, maybe. And so when you have a positive current and a negative current adding together, you get 0. So it's not that there's no current anywhere. We're just saying that the current right here and right here is 0. And like I said, I hate to keep saying this, that you'll learn more about this in electronics, but you will learn more about it in electronics. So, but it does seem at this point, I was exactly where you are. It's like, I don't believe this. It doesn't make any sense. Like, really? And, every time we asked our circuits instructor, he would just say, don't ask what's inside the op amp. And so I thought it was like a big secret, but it's not. It's just something you learn about later. So, all right.